Your homework for 2/28/2013, Chapter 7, Lesson 6. If you brought your binder home, you will need your book, page 567. If you do not have your binder, then you need a piece of graph paper. Please put your heading at the top. On your book, page 557, please put your name and the date 2/28/2013. Example number 1, which is question number 10 on page 567, says graph each pair of similar triangles, then write a proportion comparing the rise to the run for each of the similar slope triangles, and find the numeric value. That must have gotten cut off. So triangle LKM has vertices -4, +4. You're going to plot the points. -4, -4 for K. And M, which is 2, +2, -4. And then with your straight edge, you're going to connect those points and make a triangle. And it happens to be a right triangle with this being our right angle. Then we're going to plot the points, triangle NPM, with vertices N, -1, 0, P, which is -1, -4, and M, which is the same point from the larger triangle, 2, -4. And I'm going to switch colors and trace that triangle, preferably with a straight edge. However, I can't use one on this program. So now I have my two similar triangles. And so I need to find a proportion that compares the rise over the run. And if I use the line LM and I count the rise, I'm actually falling. I'm going down and then I'm going over. So I'm counting down 1, 2, 3, 4, 5, 6, 7, 8 over a run, which is 1, 2, 3, 4, 5, 6. Then I want to take a look at the smaller triangle, the red triangle. And from N to M, I am counting down 1, 2, 3, 4, and over 1, 2, 3. So, -8 over 6 does reduce to -4 over 3 because both are divisible by 2. And so that's the proportion they were looking for in a numeric value for the slopes. Example number 2 is question number 11, just like question number 10. So if you would like to pause the video, you can pause it and do the question on your own and then play it back to see if you get the same answer. Triangle ABC is at -5, -6, which is down here in quadrant number 3. Point B is 1, -6, which is over here in quadrant 4. And C is 1, 3. So a rather large triangle. And we're going to try and connect the dots. You would use your straight edge. And I'm going to go back and label those points. A, B, and C. And GFD has vertices, now let me switch colors here, -3, -3, which is here, -1, -3, which is here, so this is a smaller triangle, a dilation, it was shrunk, and 0, -1, which is here. Okay, if I connect the dots for this smaller triangle, I get this red triangle, which is G, F, D. And I want to write a proportion comparing the rise over the run from A to C and then G to D. So I have the value from A to C as the rise 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going in the positive direction, and over 1, 2, 3, 4, 5, 6. And 9 over 6, in the end, will reduce to 3 over 2. But let's see what the rise to the run is for G to D. From G we go up 1, 2, 3, and over 1, 2, which is the same or equivalent ratios that we have here for the slope. So those are the proportion that they're looking for. We don't have to include this. All we need is this proportion, and the numeric value of the slope of the line would be 3 over 2. Example number 3 is question number 12. It's a Common Core question. It says, use a graph to find the missing coordinates for point Z if the two triangles are similar. And we did something like this in our exit slip today. And we can start with M and P is -2, -3, 2, -3, and 2, +3. So here's our triangle. And that's M, N, P. And then triangle XYZ is similar to this, and it goes from 0, 0 to 2, 0, and then we have to find the Z coordinate. So this is one side of the triangle, and if we're looking for similar triangles, we're looking to make a triangle right here. And so the coordinates of Z are also the same as the coordinates of P, which are 2, 3. Question number 4 is question number 13 on page 567. It says use a graph to find the missing coordinates for point Z if triangle MNP is similar to triangle XYZ. So triangle MNP is at 5, 0, 5, -3, and 2, -3. Here's M, N, P. And XYZ starts at 7, +2. Switch to red so we can see it a little bit better. 1, 2. And where is the third point that makes these two triangles similar? So if we continue that side that they would share slopes, if we extend that line, and we have to still include the right angle, looks like our triangle X, Y, Z has coordinates of Z that are 1, -4.